Hi, welcome back. We are doing Circles Part 1, Lesson 9, which is more practice on inscribed angles, central angles, inside and outside angles. So it's kind of a big practice of all the angles mixed together. Okay, what we're going to do is, I hope you have this big picture printed, and we're going to work through this one kind of together. Make sure we can find all 10 angles. Okay, what I've done is I've gone ahead and printed up this, and I've gone ahead and labeled the given information, but let's review it real quickly. We've got BE is a diameter, so we have a diameter right here, so we know we've got 180 on each side. Okay, we also know that AT is a tangent, so that means point A is a point of tangency, and we can assume that that's a tangent line. AB, the arc from A to B is 80 degrees, and the arc from B to C is 20 degrees. Notice those actually look almost the same size. So this is not drawn to scale, so don't be surprised if we get some odd angles here. And then DE, which is this smaller arc up here, is 50. So I've labeled those three angles already. Now we're trying to find all 10 angles at the bottom of the page. But rather than being focused on just like finding angle 1, finding angle 2, we're just going to work on the diagram and then go back and fill in our answers. Okay, so let's go through and see what we can figure out. Well, immediately I know that if this arc is 20, my central angle right here must be 20. Okay, and if I know this is 20, then this side is its linear pair. So this side must be 160. Okay, so I can immediately start doing those. Now, let's go to this 80-degree angle, or arc. This 80-degree angle arc is part of the bow tie. Do you see the bow tie? Angle 3 we can get from averaging, using the bow tie rule, these two arcs, the 50 and the 80. So the average of 50 plus 80, let's just 50 plus 80 is 130 divided by 2. Is 65. So that means this is a 65-degree angle. So we actually have angle 3. We have an angle 8 so far. Okay, so now let's see what else we can get. Angle 1 up here, what type of angle is it? It's an inscribed angle. So we need to look at the intercepted arc. Let's extend the sides. So we're going from, oh, it's arc AB, isn't it? Because if we extend the sides of angle 1, we get from A to B. So if this is 80, angle 1 is 40. Okay, so let's see. Angle 2, let's see what arc it intercepts. It is also, the vertex is on the circle. So if we extend both sides, we're going from A to C. So what is the arc measure from A to C? Well, it's 80 plus 20. So it's 100 degrees in its intercepted arc. So since we're going backwards to the angle, we're going to take half of the sum, so that's 100, so this one's going to be 50. Okay, so we now have angles 1, 2, and 3. Okay, let's look for another angle. How about angle 4? That's one of those outside angles. And if you remember, we have two intercepted arcs, the larger one and the smaller one. So what is this formula for an exterior or an outside angle? Big minus small divided by 2. So the big arc is from A to C. See how that extends? So from A to C is 100. So we'll take 100 minus 50 all divided by 2. So 100 minus 50 is 50 divided by 2 is 25. So that means angle 4 is 25 degrees. Okay? Now let's see what else we can see. Let's go on to angle 5. Angle 5 is a tricky angle. It's this angle right here. So look at it carefully. What type of angle is angle 5? Well, angle 5's vertex is A, and we know A is a point of tangency. So it's on the circle, and when a vertex is on the circle, it means it's inscribed. Even though we're dealing with a tangent, you always look at where the vertex is. It's on the circle, so it's half of the arc. Well, what arc does it intercept? Well, it's going from A to B, isn't it? So this arc is 80, So we know that we're going back to the angle, which makes it smaller. So this is 40 degrees. Okay? Angle 6 right here is also an inscribed angle, and it also has A as the vertex. But let's extend the sides to see what we have here. We have one side of it is from E to E, and the other side of it is to B. What do we know the arc from E to B measures? Well, they told us that EB was a diameter. And if EB is a diameter, that means that's not 180 degrees. And when we have a triangle inscribed with the diameter as the hypotenuse, we know it's half of that arc, right? So if this is 180, angle 6 is 90 degrees. So that's a right triangle right here. ABE is a right triangle. Okay, let's see which other ones are we missing. We've got 8 already. Here's 7. Okay, look where 7 is. Its vertex is on the circle. It is also an inscribed angle. Extend the sides. So we're going from A over to E. A to E. Okay, we need to know that arc. We don't have that yet. But we know BE is a diameter. We know this part is 80. We know this part is the other half of the circle. So let's see, 80 plus 100 would make 180 for the diameter. So this arc has to measure 100. That means if we work back to the angle, that's got to be 50. Okay, so angle 7 is 50. We have angle 8. We're up to angle 9. Okay, here's angle 9. Notice 9 has a vertex at A. What are the sides? Let's see. From A it goes to D. From A it goes to E. So we need to know this arc. Well, they gave us that one. That's 50. So that's inscribed. It's half. So angle 9 is 25. Okay, looking at angle 10. We're down to our last angle here. Let's see. Angle 10, the sides are A to E and A to T. Okay, again, angle 10 is like angle 5. It's tricky, but notice the vertex is on the circle. That's how you decide what type of angle it is. So this one's inscribed. So from E over to A, what's the arc? The arc is 100. Therefore, the angle that's inscribed has to be 50. And there you go. That's how you would figure those angles and arcs out. So anyway, those are the 10 angles, and you can fill in at the bottom if you need to. So there's that diagram. Now, we've got a few more mixed angles on the next page. And I've got these printed, and I hope you can see they printed kind of lightly, so I'm going to try to zoom in best I can to help you guys. Okay, so let's focus on number 1 here. Number 1, we have just a single inscribed angle. The arc is 75, so what do you know the rule is? It's half. The angle's half, so it's 75 over 2, or 75 halves. Okay, let's look at the second one here. Okay, the second one is also inscribed, but we're working the opposite way. We're given the angle is 85. So to work from angle out to the arc, we're going to double it. So multiply it times 2. And that's 170. So 170 degrees is number 2. Okay, number 3. Number 3, we have a point right here and an angle. So we're trying to find this angle, and that angle is an inscribed angle, isn't it? Because the vertex is on. This is one of the tricky ones. You've got a tangent and a secant, so it's kind of hard to see it. We need this arc right here to be able to figure out angle 3, or we need this angle and find its linear pair to find angle 3. I'm going to show you 2 ways to do this one, okay? The first, I'm going to do the arc first. So if this is 240, what is left out of 360? Well, 360 minus 240 is 120 degrees. That means this arc is 120, and that's the intercepted arc, so we take half. So angle 3 is 60. Okay? Another option is to first find this angle. Okay? This angle up here has the intercepted arc of 240. If I take half of it, I get 120. And then its linear pair is 60. So 2 ways to do that problem. Okay, let's look at this next one, number 4. What kind of angle is number 4? It's a central angle. So this one is so easy, you might have forgotten. If the arc is 135, then the angle is 135. Just as simple as that. Okay, so here's number 5. What type of angle? Central angle, 96. So what do we know the arc is? 96. Number 6. Number 6, we have a central angle. And so what we can do is say, okay, if this is the central angle, we know the arc has to be the same. So the arc measure is 70 also. Now notice angle 6. Where's the vertex? The vertex is on the circle and is intercepting that same arc. So if the arc here is 70, what's the angle? It's half. It's going to measure 35 degrees. Okay? Now, number 7 is that rule about the quadrilateral inside the circle. What do we know the relationship is in the opposite angles? The rule is the opposite angles are supplementary. So if this angle is 80, angle 7 must be 100. Because remember, if the angle is 80, this arc is 160, which makes this side 200, and then we're working back to the inscribed angles. So that's the rule, and that's where it comes from. Okay, and number 8, let's see. Where is our angle? It's in the circle, but it's not at the center. So what was this formula? This is what I called the bow tie rule. So let's darken the arcs right here. See if you can see it. The arcs are 160 and 50. Okay, the angle is on the inside, so we're going to add and divide by 2. So the rule is 160 plus 50, which is 210. And 210 divided by 2 is 105. So that means angle 8 is 105 degrees, and its vertical angle is also 105. Okay, so there are the first 8 of the review problems. Let's go through the last few on the next page, or at the bottom of your page. Okay, here are the next ones. Number 9. Okay, this is an outside angle, but this one's tricky because you don't have the 2 given arcs. You're going to have to subtract, divide by 2, and then set it equal to 30. So this is one of the backwards problems. So I'm going to call this arc up here X because it's my unknown. I'm afraid that we're going to get confused if I use a 9. So let's say X minus 47 all divided by 2 is equal to 30. Whoops, 30. Then remember we put a 1 under it and do a cross product. So I'm going to get 60 is equal to X minus 47. So what is X equal to? It's just going to be 60 minus 47, or 13. So, oh, wait a minute. I'm going to add those together, not subtract. 60 plus 47 is 107. That sounds better. So that means this large angle up there is 107 degrees. Okay. Let's look at number 10. Number 10, we're dealing with a tangent and a secant, okay, or a tangent and a chord. Okay, we have this side is 156. We need this angle right here, or the arc. I'm going to give both because I can't really tell if they're wanting the angle or the arc. So let's give both of those. What do we know about a straight line? It measures 180. So if we subtract 156 from it, that leaves us with 24. So that means this angle over here is 24 degrees. But if they're asking for the arc, which I'm not sure which one they're asking for, so again, we're going to give both. So the angle is equal to 24. But the arc, we would take that and double it, would be 48. Okay? Because you just multiply by 2 for an inscribed angle, and that's the trickiest, the tangents. Okay, let's look at number 11. Number 11 is one of the angles that's inside the circle but not at the center. So we're going to have to use the bow tie rule, and use this arc and this arc. And remember, we do what? We add and divide by 2. So I'm going to make angle 11x. So x plus 105 divided by 2 is equal to 154. Again, stick a 1 underneath it, do a cross product. So x plus 105 is equal to what? 308? 308 minus 105 leaves us with 203. So x is 203 degrees. So this arc is 203. Okay? That's how you'd find that one. So when you're missing one of these, you just set it up with a variable. X plus 105 divided by 2 is equal to the angle. Okay, let's look at number 12. Number 12, we have an exterior angle. We need the one where we do the big or the larger arc minus the smaller arc divided by 2 is equal to the angle outside. Okay? So our big arc, or the arc inside the mouth, the larger one, is 100. We don't know the smaller one, and we don't know this outside angle, do we? But we can figure one of them out pretty easily. Okay, we can figure this arc out. And how are we going to do that? Well, we have this side is 150, this is 100, and this is 60. So if we add all those together, we get 250, 310. 310 from 360 makes this angle or arc 50. So I just subtracted these 3 angles from 360 to figure out what was left for this smaller arc. Then I take big arc minus small arc divided by 2 is equal to the angle. So 100 minus 50 all divided by 2, that gives us 25 degrees. So angle 12 is 25 degrees. Okay. We're down to the last few down here. Let's see how we're doing. Okay? Let's see. We are trying to find this angle right here. That's going to be really tricky. We need to know some intercepted arcs. And I don't think we have enough information. Or do we? Okay, we know that angle 66. So what would this angle right here be? Well, we're going to take 180 and we're going to subtract 66. Again, I don't want to make silly mistakes on here. So 180 minus 66 is 114. So this angle is 114. Okay, this arc is 114. That is telling me that is a central angle. If this angle is 114 and that arc is 114, that means that has to be in the middle. That means that angle at 13 has got to be 66 degrees. It doesn't look like it's in the middle, but it actually is, and that's how we know. Okay, now let's look at 14. Okay, 14 is one of these outside angles. Okay, let's extend the sides. Okay, we have 2 intercepted arcs, a large arc and a small arc. Actually, we have both of them, so this one's pretty easy. 132 minus 36 divided by 2 is equal to our angle. So let's subtract those. Yeah, you guys can see that. So 132 minus 36 is 96. Divided by 2 is what? 48 degrees. There we go. Okay, so angle 14, or number 14, is 48 degrees. Now let's do these. These actually have two angles we're looking for each of the diagrams. Okay, which one can we figure out more easily? Well, we've got an angle that's in the circle but not at the center, so I'm going to draw the bow tie rule. Okay, 54 is one of my intercepted arcs, and 48 is one of my intercepted arcs. So I can figure out 16 first. So 54 plus 46 is 100. And then half of that, because I have to divide by 2, is 50. So that means angle 16 is 50 degrees. Okay, so let's go up and put that into the diagram, 50 degrees. Now, what do we know about these two angles? They're supplementary. So if this one's 50, its vertical angle's 50. So that makes angle 15 supplementary to either one of those. So that makes it 130 degrees. Okay, last one. See what we can do. Okay, let's look at angle 17 and 18. Where's the vertex? 17, the vertex is on. 18, the vertex is on. So that means they're both inscribed angles. So let's look at 17 first. The inscribed, or the intercepted arc, is this arc, and we don't have its measure. But we can figure it out because we have this side, which is 162, and this side, which is 160. So let's add those together. 160 plus 162 is 322 from 360. Let's see, we got 38 left over, so 38 is the arc. And then we know this angle is half because it's inscribed. So half of 38 is 19, so that's 19 degrees. And then angle 18 is also inscribed. But we have the intercepted arc, don't we? This arc is 162, and again, it's the tangent with a secant, so it's a little trickier to see. But the arc is 162, so we just take 162 and we divide it by 2, and voila, 81. Okay, so 81 is the measure of angle 18. Okay, that is the end of Unit 9. You are finished. Okay, Unit 9 is complete. You have finished all the lessons, and you should be doing this at this point. Circle, 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 arc. Whoops. Let me zoom out for you. Circle, 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 and arc. You should be feeling like this at this point because you have finished this unit up. So good luck. Let me know if you need some help.